Hi guys, hope you can hear me. I'm Francis Krasta and I'm the Product Marketing Manager for Motor Protection and Safety. Today I will help you understand what goes into a contactor, how it operates, what are the main components, specialty of an AF contactor, and also some basic selection guide. I won't go in detail. Basically, I have just 30 minutes and then I will try my best to actually cover as much as possible. And also I will go through a different type of contactors for different application. So just to start with, I would like to ask a simple question. What is a contactor? Basically, a contactor is a switch which switches on and off an electrical circuit. So it can be done electrically. Okay, so this is what you can see on the screen, is basically the control side of it. It can be done electrically or remotely via push button. You can do it via PLC. Basically, for PLCs, you have different kind of contactors which can handle that low power output from a PLC. And the bottom part is basically the power side of it. So the contactor is dimensioned based on the voltage of the system, and also the current, what is going to break or make. So say for example, if it's a motor, you need to make sure what is the kilowatt rating, what is the current, and depending on the current, the size of the contactor basically changes as well. More the current, bigger is the contactor. So I will talk about our AF technology. Why is it different? We were the first company to basically bring this technology into the market somewhere in mid 20s, and things have changed. After that, people have tried copying us. People have asked us if we can sell them our design, but of course we didn't do it. So what is different to a conventional coil? So conventional coil basically has, as you know, that there is a laminated core, and you have thin wires which are wound on it. It's basically to create magnetic flux. But with our electronic coils, we have three sequence, basically closing sequence, holding sequence, and opening sequence. So with the closing sequence, what happens is as soon as the contactor receives a closing signal, the processor inside the contactor starts checking for voltage, measuring voltage and current. And if there is right energy, only then it will close, or else it won't even start the process. This makes sure that there is no welding or is no chattering of a contactor. The voltage can be AC or DC, because no matter what you're applying to it, there is a rectifier which converts it into DC, because that is exactly what is used. DC is used for the PCBs. And then once you finish this closing sequence, you go to a holding sequence. And in this sequence, the processor continuously measures the current and voltage, and it makes sure that just the right energy is applied to the coil just to hold it. So no excess energy, meaning there is no wastage of energy, which is in the form of heat, and that is most of the times the life of the coil basically decreases because of that, and the coil burns because of overheating. And once you finish that, once the holding sequence is done, and once you want to open the contactor, as soon as you give a signal that is remove the voltage, the processor detects it and distinctly opens it in 3.5 period. So this is what exactly the internal sequences and what it does. Now this is how it looks like. If you see, there is a coil as well in this one, but this is an optimized DC magnet, and it's controlled by a electronic circuit. Okay, so with all the as you know, voltage and current is continuously measured throughout the cycle. So it making sure that you have good closing, holding, and opening sequence, and also there is a strong making force as well. Humming and buzzing sound is eliminated, and there is low heat dissipation. This technology is used in all our contactors from AF09 up to AF2850, and this is one of the biggest contactors in the world at the moment, block type contactors. And if you ask me where it is used in renewable energy, that is wind farms. All the wind turbines will have AF contactors. So we have a complete offering from motor control and up to for power distribution as well. I will go through some of the features and why we are different compared to rest of the people in the market. So previously we had AC and DC contactors, as you can see in the picture. Now both of them, we don't have to use two separate contactors, whereas we can use only one contactor which can handle AC or DC control voltage. 40, because of the electronic coil, 45 coils are now reduced to just 4 of them. Okay, so for example, you have a 9 ampere contactor that had around 45 different coils, 24 volt AC, 24 volt DC, 60 volts, 48 volts. I mean, the list goes on. So there are 45 in total that now has been reduced to 4 coils. Now, on the screen you can see there are only 4 coils. Code 11 goes from 24 to 60 volts. Code 12 goes from 48 to 130 volts. Code 13 100 to 250 volts, and 14 from 250 to 500 volts AC DC. So code 13, which is 100 to 250 volt, is our biggest runners, not only in Australia but around the world. And this is the example what I can give you for one coil 100 to 250 volt. You can service entire world, actually globally. They are using it. So for example, in Europe, 110 volt, 127 volt, 220 volt, 230, 240, 50 hertz. You have only one contactor. If you are a manufacturer of a machinery which is exporting to anywhere in the world, this is the contactor for you. In Asia, it is 110 volts, 220, 230, 240 volts, 50 hertz or 60 hertz. Basically, in North America, it's 120, 60 hertz, and in some part of the world, they even use DC, 100 to 250 volts, anywhere in between. So this basically, this particular one contactor can be used throughout the world, and it has all the certification, UL rating, it has IEC, it has CCC, and only one part has all those testing done as well. So talk about coil operating limits. We have, as per IEC, every control coil needs to have an operating limit, a tolerance. So minus 15% of the rated voltage to and plus 10%. Our conventional contactors used to do 220, 230 volt. Okay, they used to rate it at 220 or 230. And minus 15% is 187, and plus 10% is 253. So one coil could operate without any issues from 187 to 253 volts. Okay. Now here with AF coils, hang on, there is a message. I just have a message from a speaker who actually cannot connect for some reason. So with our AF coil, it goes, since I'm just giving an example of one coil which goes from 100 volts to 250 volt. With the tolerance, with the IC standard, it can go minus 15, 85 volts, and can go up to 275 volts. Okay, so the limit has been increased now. So the operating limit, safe operating limit, is from 85 volts to 275 volt for that one coil itself. We have something called as the dropout zone as well. IEC actually governs this as well, and as per IEC, the dropout zone must be somewhere around 75% of the rated voltage, minimum rated voltage, and the dropout or sorry, the yeah the it basically it needs to stay closed for 75% of um, rated voltage min. Okay, and whereas it needs to drop out 25% of the rated voltage. So in both the cases, in a conventional coil, the dropout zone is uncertain. Okay, it may or may not. Okay, but with AF technology, because there is a microprocessor inside, okay, and it's programmed, we make sure that 60%, if it goes below 60% as well, it will still stay closed. Okay, so now the safe operating voltage has gone from 60 volts to 275 volts. So how good is it for AF contactors? And even in fluctuations, you can basically rely on this contactor. Built-in surge suppressor. So based all contactors, most of the contactors, they use surge suppressors. In previously we had around 18 different parts, but now with our AF contactors, because of the electronic coil, these is built in. Okay, so you don't need any additional contactor, or you don't need to go through the catalog to select which is the right surge suppressor. So this is one of the example. This is from an oscilloscope, and so this graph is of 42 volt, 50 hertz, a coil. Okay, when the and this is the surge which is created. This is around, the peak is around 3,500 volts. Okay, and with the conventional technology, it basically used to clip the peaks, but the residual over voltage used to still remain either of AC or DC. But with the AF technology, it has almost eliminated. It is smoothened it out, and there is no residual over voltage as well. So basically, the life of a contactor has increased because of it. We have also reduced the size of our contactors. So for example, our 26 ampere range, previously it was 55 mm, now it is just 45, so reduced by 10 mm. Whereas with a bigger size, that is 210 amperes, now the same contactor is called as AF 205. The size is reduced by 35 mm. And when I say reduced coil consumption, and so this is the graph where it shows for AC coils. So previous conventional coils, the pull-in was around 70 VA. Now it is just 50 VA, and the holding is just 2.2 compared to 8 VA. For DC, it has reduced quite a bit, from 6.6 watts. Now it's only 1.7 watts. This, because of all these, because of the less heat dissipation, it is possible to group mount it without any spaces in between, and the size of the control cabinet has just decreased drastically. I have many of the customers who are using this, and they're using it as group mount as well. We have accessories for our contactors as well. So it's just basically just clip-on accessories, very fast and very quick. So the front block connects the two built-in NC auxiliary contacts with the two coil supplies in one click. Okay, how I mean, I've assembled it myself, and it is really tool-free and really quick. So we not only stopped with all the electronics and all those stuff. Okay, so we also worked on our accessories as well. um, so as per IEC governs all the markings as well. So there are marking rules set by IEC. So because of that, we had around 11 different kind of contact blocks front mounting. So if you want one NO, you have to use a four pole contact block. If you want two pole or two NC or two NO, you still have to use a four pole contact block. But now we have changed our design and we have a universal marking codes. And because of that, we have changed our four pole into just a single pole. So single pole for NO, normally open contact, and normally closed contact. So this is especially good for OEMs and for wholesalers because they invest heaps in inventory, whereas this has helped them reduce the inventory costs as well. With all these benefits, I would argue why won't you use our AF contactors? So it has high reliability, high withstand shock and vibration, long life. It can do AC DC, wide voltage range. You don't even need a surge suppressor. Hardly any noise during holding. It's hum free, and the specialty about it, this is the only contactor which can be used for semiconductor industries, because it can take a voltage dip of 24 milliseconds, and that is very long. So no contactor in the market which can do that at the moment. So we are certified for it as well. And basically there is no voltage drop, no bouncing of contacts. Now, how do you select the right contactor? This is again something what I'm going in just brief, not in detail. These are some of the main criteria which you need to check in. Duty cycle is very important. So for motor control, if you see direct online, the making current is around 6 times the nominal current, whereas the braking current is just same as the nominal current. That is an EC3 application. You have a star, delta, star then. The making current is just 3 times, and there is an inrush basically during the transition period from star to delta. That's where the inrush is. And then you have a AC4 category, which is inching and jogging. So inching is 6 times nominal current during making and also braking. So this is one example what I can say that in Australia, we use in mining, underground mining, we use inching and jogging to start their exhaust fan, which is 110 kilowatt and 1000 volts. It has always confused me that people who do inching and jogging, they still don't know that they are doing inching and jogging. They still think that it is a dual start. So you need to make sure if you are repeatedly starting it and giving break for a few seconds, meaning that it is inching and jogging, it is not a dual start. We have some other application as well. We have heating resistance, so making and breaking current is the same. It is AC1 category. We have capacitor switching as well, which is around 100 times. We have special contactors for capacitor switching, which can handle making 100 times the current. It is basically the internal pole configurations are totally different. They are not flat, they are hook type, so they have no chance of welding. And there is dynamic braking. I mean, this type of application I come across hardly. I mean, I have not come across till now, basically. But this type of there is a category for it governed by IEC for this. So this is the selection chart what we have in our catalog. So it is clearly mentioned over here. So we have AC1 category where you can select a contactor based on the current. You can select it based on your AC3 category, because these are the two categories which are used mostly around the world, and we have done a test based on that. So these are the main factors. And then you have electrical durability as well. So how many operations can a contactor give? So if you see in AC1 category, if you have a 26.5 ampere of current, AF26 will give you around 2 million operations. Okay. If in case there is AC3, if you're starting a motor with the same current, then it has drastically changed the number of cycles. It has gone to 1.2 million, around 1.2 million cycles, and it will more decrease if it's AC4, because it's inching and jogging. It has gone to around 1.1 million. So these are very important things which you need to consider to get more life of what contactor. The same contactor can be used for AC1, AC2 and AC3. The only thing is that the life of it depends on what you are selecting. So if you want around 2 million operation for AC4, then you go for an AF30 or AF38. This will give you around 2 million operations. It will, yeah, it is around AF40, sorry. Yeah, it is around AF40, which will give you around 2 million operations. Go through application specific contactors. This is how I went through this to my previous webinar as well. This is the ideal case how you will basically connect a contactor through, protect a contactor either through manual motor starter and a contactor. If you're using an overload and a contactor, then you need to have a short circuit protection as well. So you either use a switch fuse or you use magnetic only manual motor starter. You can use an electronic compact starter, which is the compact starter at the moment. It can not only do DOL but also start, delta and reverse starting in the same size. But you need a short circuit protection as well, because it can do electronic compact starter can do only overload. You can have a configuration with a mini contactors as well. And finally, we can have with a contactor and an MCCB if the current is above 100 amperes. So manual motor starter, the selection guide is very easy. You need a current, and you need a short circuit breaking capacity, which you can find it in the catalog. Depending on that, you can select it. For overload relay, of course, you will have the current which is on a motor or whatever you're protecting. It will give you that kind of current. And then you need a tripping class. So tripping class basically is the tripping time. So for class 10, it goes from around 2 seconds to 10 seconds, and it can be used for a standard type of compressors or pumps. Class 20 from 6 seconds to 20 seconds. It is for a fan coil which takes time to actually speed up. So you need the inrush is for a few seconds. And for class 30, it is basically heavy duty start for crushers, for example, and can go from 9 to 30 seconds. So these are the main settings which you need to consider when depending on the applications. We have contactors for safety applications as well. They were launched somewhere last year, and they go from 9 ampere to 750 amperes. They use the same technology, okay, as our AF contactors. We have all the failure rates available. Of course, we have to during testing, and we have them. They are even compatible with our safety PLCs. Wide range of coils, just like AF, because the same technology again. We have them with cable clamps and bar type connections. It goes for the same for the smaller range as well. So as I told you, it goes from AFS 09 to AFS 750. We have the same contactors are rated for CE, IEC, and UL, so you don't have to use different contactors for different countries or different zones. DC applications. Again, I have covered all these things in very short, because we have I had heaps of presentations to cover, slides to cover. So Okay, in DC we use two pole in series, and why, I will just explain you why. So as you know, in DC you don't have zero crossing, just like AC. So what happens is, connecting them in poles, in series, you break them at two zones, so upper zone and the lower zone. So for example, pole 1 and pole 2, so the voltage is distributed and the arc is quenched easily. Okay, so that's why we use 2 or 3 poles in series, or sometimes 4 poles as series. It depends on the voltage your voltage your system is, or voltage you're breaking, basically. So we have AF, GA, GAF type of contactors for all these for DC as well. So this is a simple selection chart what we have in a catalog. It has DC1, DC3, and DC5. And depending on what are the current and voltage, you can basically select the contactor. You have also um, how you need to connect is on the left as well. So either 2 pole in series or a 3 pole in series. If the voltage goes beyond a particular voltage, you have to connect 4 poles in series. We have special contactors for DC alone, which is GAF type of contactors, and they are especially used in PV solar application. They go up till 1000 volts DC1 category and 2050 amperes. So I've noticed in Australia that for some reason in solar application they use DC3, and basically DC3 is always, as I showed you in my previous slide, it is for motors, it's for high inrush. So if there is no high inrush, because most of the time the ramping up and ramping down is done by the inverter, so why would you go for a DC a 3 rated contactor? It is always a DC1. That's what even all over the globe they are using the same I mean same category. They don't change it. So yeah, we do have GAF contactors, especially for DC switching in solar applications. This 2 pole contactor, 1500 volts, especially launched last year, end of last year. It's 2 pole, and it is not DC1. It is basically PV3 and PV4 rated. So this explains you a bit. In DC solar, the PV solar inverters differ significantly from standard DC1 application. So DC1 devices are designed basically to switch under a load, whereas it doesn't happen in solar. Ramping up and down is done by the inverter. And the new IC utilization category from 2018, there is a category DC PV3 and DC PV4, especially for solar applications. Okay, and we are the first company. Okay, ABB is the first company to actually launch this, and we are certified for PV3 and PV4 applications. So in short, there are general 2 pole 1500 volt DC contactor, 750 volt per DC per pole, bidirectional switching, first ever DC PV3 rated contactor. No one has it at the moment. They might be thinking of it after looking at our product. So there are 2 sizes. There are GF 875 and GF 1050, and of course we have approval. The same contactor is approved for CC. We have certifications for UL and IC as well. See, this is the application. So in central inverters, it's always it is required that the PV string is disconnected for grid stabilization. So you need to make sure that the PV cells are disconnected, and you need these contactors to switch this to disconnect the panels from the inverter. So that's where you can use this, and it can do remote switching, automatic switching. yeah, it is very efficient, and it's also why just some people must be wondering, why can't we use a breaker or a disconnector? So the only difference is it will give you contactors, gives you more life out of it. It has the mechanical life is comparatively much more better than a disconnector or a breaker. We have contactors especially for railway applications. So in railway, because there are lots of vibrations and the terminals used are totally different. So for gate control, heating, flaps, containers, lighting, brake, heating, everything, you need you need a contactor, and we have a contactor or a product for it. So this is the this is our entire range. We actually received a certification back in 2009, and it is international railway industry standard certification. So we have products on not only contactors but also dual starters, manual motor starters are also certified, overload relays. So we have a complete solution for rolling stock. And they are certified basically for all over the globe. I mean, you can, the same product can be used either in US or Europe or even Australia. This push-in spring starting solution, the next generation spring technology, this basically we actually launched it again. We did quite a few things last year, so we launched it last year. This is the next generation of spring technology. Of course, you know that there is spring technology in the market, where you basically put in your cables. To put in, you need to first press the spring, okay, via screwdriver, and then insert the cable. But with this technology, you have two types. Basically, it's two in one. It has spring technology as well as push-in, where you can save almost 50% in wiring. No tool is required at all. So two-in-one connection. One is a push-in mode, where you have rigid cable or a cable with your lug, with your pin type lug, and spring mode, where you have cables without a lug, or if it's a flexible cable. So in push-in mode, you just push the cable, which is either with a pin type lug or a rigid cable, and yeah, you don't have to tighten it, nothing. It is just basically, it just tightens itself. So you save around 50% of wiring time. And in spring mode, where your cables are without any lugs, pin type lugs, so you actually insert a screwdriver and push your cable. So no twisting or turning is required, and it is a very safe solution as well. We have all the smart accessories. So just imagine you are assembling a star delta starter or reversing starter. You have all the tools, you are just pushing them without any tools, and how good it is. It will save heaps of wiring time for sure. We have a complete solution up to 18.5. This is especially for group mounting, or say for example for control type of market, where you have a lot HVAC. You can say for example HVAC, where you have heaps of contactors, you have lots of fans, and you have lots of wirings to do. So this solution will save you heaps in wiring cost. No need to tighten because we don't have screws. So what happens is, when, say for example, you're manufacturing it in your factory, and then when you or a workshop, and then when you send your panels to the site, you have to reconnect them every time. But this one it makes sure that you don't have to retighten it, because it doesn't have any screws. You just push in and make sure that the toughness is still there. It's vibration proof as well. So pull out and flexion on each pole according to IEC. So we have tested all these of tightening or vibrations. The shock and vibration, we have tested it to IEC 6068-2-27 and IEC 60068-2-6. So yeah, we have tested our products based on the vibrations as well. So with this, I end my presentation, and if you have any questions, just let me know. I think Isabel is online.
I sure am. So I'll be able to take
Isabel,
you through. Can you hear me?
Yeah.
Hello?
For some reason, I cannot hear Isabel as well.
Oh. Okay. Not sure. Hello?
You can type in any questions, and I will answer it.
Hello?
I can see over here, hopefully, any
Hello,
questions.
can you hear me now? Hello?
Yeah, there is some technical issue today, and yeah, and one of our speakers, basically organizers, cannot jump in.
I believe that.
So, anyways, whatever questions you have, I recommend you to basically type in, and I can't hear them at the moment. I can't even see them because only the organizers can see it. Once you do that, I will send you guys a reply via email. That is the best what we can do at the moment. Sorry about the inconvenience, but yeah, we don't have any other option.
Thank you, everyone. As Francis said, we are having technical issues. He can't hear us, but clearly you can hear me.
Since we can't do much, thank you for joining my presentation, and I will be having my presentation somewhere in August for UMCs. Join in and make sure that you get most out of it as well, because it is a good product, and you will get lots of knowledge, and especially for consultants. Yeah, it is a very good solution as well. Hope you guys join me in August as well for our UMC. Thank you.